Hi everyone. For this video we're going to be taking a look at a couple of what we call special right triangles, and you'll see what I mean in a minute about what makes them special right triangles. First of all, take a look at our objective for this video. We are going to, by the end of this video, be able to determine the lengths of two sides of a 45-45-90 or a 30-60-90 triangle when the length of the third side is given. So that's what we're looking at doing by the end of this video. So first, a little introductory information here. It says in most cases, in order to apply the Pythagorean Theorem, remember that's a squared plus b squared equals c squared, you must know two of the side lengths for a right triangle. If you're going to use a squared plus b squared equals c squared, you need to know two of these three variables so that you can find the third one. If you only know one, you're not going to be able to solve for the other two, because we know from our Algebra 1 lessons that if we have more than one unknown in an equation, we can't get a single correct answer. So if we're going to use a squared plus b squared equals c squared, we need to know two of the sides to find the third. However, there are a couple of special right triangles where it is possible to find the lengths of two missing sides when only one of the side lengths is known. And that's what we're going to be looking at. That's what makes these triangles special, because if we just know one of the side lengths, we can actually find the other two. Now, the first of the special right triangles, it's called a 45-45-90 triangle. So 45-45-90, I guess I should put triangle there on the end of it. That name refers to the angle measures for the triangle. In other words, this is a triangle, like we can see down here, that has two 45-degree angles and a 90-degree angle. So a 45-45-90 triangle. If you look at this, you might realize that what we're actually talking about here is we're talking about an isosceles right triangle. It says, can you see why? And hopefully you'll recognize that if it has two angles that are congruent, it would also mean that it has two sides that are congruent. In this 45-45-90, since these two angles are congruent, we've learned a long time ago that would indicate that this side right here and this side right here would be congruent to each other. So it's an isosceles right triangle. Now, Theorem 8-6 kind of gives us the key for doing what we described up here, finding two side lengths given only one of the sides. It says in a 45-45-90 triangle, the length of the hypotenuse is the square root of 2 times the length of a leg. So in this 45-45-90 right triangle, we know that we have a hypotenuse, which will be across from the 90-degree angle. So I'm going to label that as HYP for hypotenuse. And we know that the other two sides would be legs. And since it is an isosceles right triangle, we also need to remember that those legs are going to be congruent to each other. So according to Theorem 8-6, the hypotenuse, I'm going to write this out, hypotenuse is equal to the square root of 2 times a leg. Or the way I usually abbreviate this is H for hypotenuse equals L for leg times the square root of 2. And if you just remember this simple little formula, it's only got three parts to it. It's a pretty simple formula. Hypotenuse equals leg times the square root of 2. You can apply that in pictures where you know one of these three sides and you can find the other two. So let's take a look at several examples where that's exactly what we're going to be doing. We need to find the value of each variable in each of these four triangles down here. And it says to write your answer as an integer or in simplified radical form. In other words, we're going to be dealing with the square root of 2 a lot in each one of these. We don't want to type that in and give the kind of the ugly decimal version of the square root of 2 or of our answer. We want to leave it as a radical. So if I look at example A here, I have my 45-45-90. I know it's a 45-45-90 because it has a 90-degree angle here and two of the sides the same. So I know that this is a 45-degree angle and I know that this is a 45-degree angle. And I need to find the value of x right here. So the first thing you want to do is either you mentally or literally on your paper kind of label for yourself where the hypotenuse is and where the two legs are. so that when you apply this formula, you can put in the appropriate values for the h and the l. So the next thing I'm going to do is I'm going to, over here, I'm going to write out my formula. H equals L times square root 2. And I would really recommend that you start by writing that. Because if you do this on your homework and all your practice problems, if you write that formula out every time, you're going to eventually have it memorized. You won't really have to put any special effort into trying to memorize this. You'll just have written it 20 or 30 times, and so you'll know it. So I start by writing my h equals L times the square root of 2. Now I look at my picture and I just put in whatever the picture gives me for these two values. In other words, it gives me an x for my hypotenuse, so I put an x right there. And it gives me a 3 for my leg, so I'm going to put a 3 right there. And now you can see in this formula, my hypotenuse is my x, so my x is already isolated. I just need to clean this up a little bit. It says x equals 3 times the square root of 2. We know that we can write that as just 3 root 2. So x equals 3 root 2, that's my answer for part A. In part B, again, I have a 45, 45, 90. I know that because it's a right triangle where two of the sides are the same. So these two angles are 45 degrees. And I know that this is my hypotenuse, and that this is a leg, and that this is a leg. So when I start by writing my h equals L times the square root of 2 formula, the next thing I need to do is just put in the values that I'm given in my picture for my h and my L. So h, it tells me, is 6 times the square root of 2, and L is my x in this picture. So now I have 6 times the square root of 2 equals x times the square root of 2. Now for many of you, you're realizing right now that if this equation is to be true, that x has to have a value of 6. It's got to say 6 root 2 equals 6 root 2, right? But if you don't recognize that right away, you just do the same thing that you would do in any kind of equation where you're trying to isolate the variable. You look at what's happening to the variable and you try to undo it. In this case, the variable is being multiplied by the square root of 2, so we are going to divide both sides by the square root of 2. Those square roots of 2 will cancel out right there. You're realizing right now over here that we do have a square root of 2 in the denominator, and so some of you might be thinking, oh, I need to rationalize that denominator by multiplying top and bottom by the square root of 2. And if you did that, you would end up with the right answer, but you might also realize that I can just take this square root 2 and this square root 2 and cancel them, and that leaves me with just my 6. So we can see that 6 is equal to x, or x equals 6. In part C, it's going to get a little bit trickier. A and B are kind of like the standard 45, 45, 90 questions. They're about as easy as they get. It does get a little bit trickier in C. You can see here we have our 45, 45, 90, our two sides that are congruent, which would make this angle and this angle congruent. So it's a 45, 45, 90. Over here, my y is my hypotenuse, and this is a leg, and this x right here is a leg. Now to start with, we don't really have to do much calculations to figure out what x is equal to. I know that it's going to be equal to 4 times the square root of 2 because it's going to be the same as this right here. So x is done. Next, we're going to take a look at our little formula, h equals L times the square root of 2. We're going to put a y in for h, and we're going to put our 4 root 2 in for L. Now don't forget though, this is just my L. I still have this square root of 2 hanging off over here. So my y is equal to 4 square root 2 times square root 2. And so what I'm going to do here is I'm just going to quickly kind of write that out as the three things that are being multiplied together so that you can see that when I multiply these two together, that's just going to be a 2. So now I have 4 times 2, which is 8. So my y value is 8 in this picture. X is 4 root 2 and y is 8. And finally, in example D here, our 45, 45, 90 triangle has a hypotenuse of 7 root 3, and it has a leg here of x and another leg of y. So we might be recognizing right away that the x and the y will be the same. Whenever I find one of them, I know that the other one is that same value. I can set up my equation of h equals L times the square root of 2. I can fill in 7 root 3 for my hypotenuse, and I'll go ahead and put an x in for my leg, and then once I find x, I know that that's going to be y as well. So x times the square root of 2 is the right side of this equation. Just like we did up here in example B, we notice we have x times the square root of 2, so we're going to divide both sides by the square root of 2. It's going to cancel out right here, leaving our x isolated. But over here we do have to do a little rationalizing of this denominator. This square root 2 is not going to cancel with anything up here like it did for us up in example B. So we know that we have 7 root 3 over square root 2 that I need to multiply by square root 2 over square root 2. On the bottom, square root 2 times square root 2 is just going to leave us a 2. On the top, we have 7 square root 3 times square root 2. So I'm going to just kind of come over here to the side and do this. 7 times the square root of 3 times the square root of 2. Now this turns into 7 times the square root of 3 times 2, which is 7 times the square root of 6. So up on top right here, we can just write it as 7 square root 6 is our x value, and that again will also be our y value. So that's 45, 45, 90s. The next special triangle that we're going to learn about, they're called 30, 60, 90s, or a 30, 60, 90 triangle. Again, that's because of the angle measures. So these are going to have a 30-degree angle, a 60-degree angle, and a 90-degree angle. Makes them 30, 60, 90 triangles. Now if I look at this 30, 60, 90 triangle, I'm going to give these side lengths some labels. Of course, I know that the one across from the 90-degree angle, we're going to call that the hypotenuse. These two are our legs, but we're not going to just call them leg and leg, because that might indicate that we think that they are the same length. And we know they're not going to be, because the angles are not the same. So we're going to call the one that's across from the 60, this one over here, we're going to call that the long leg, because it's longer than the other one. And so, of course, we're also going to call the one across from the 30-degree angle, we're going to call that the short leg. Very creative names we have going on here. So we have our hypotenuse, our long leg, and our short leg. Theorem 8-7 is going to tell us about how do those leg lengths and hypotenuse length, how do they relate to each other. So what it says is, in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the short leg. And the length of the long leg is the square root of 3 times the length of the short leg. So you might see right away the short leg is involved in both of these little formulas that we're going to be able to set up. And that's something that you might want to remember. It's going to come in handy in a few minutes. But let's write those out in a shorter version than what it says up here in the actual theorem. We're going to say the hypotenuse is equal to 2 times the short leg. So I just shorten that down to h equals 2 times s. And we know that the long leg, which I'll use an L for, is equal to the square root of 3 times the short leg. Or sometimes you'll see that written, since we usually like to have variables in front of square roots, we'll see that L equals s times the square root of 3, where s is the short leg and L is the long leg. So these two formulas, h equals 2 times s and L equals s times the square root of 3, are what is going to allow us to do problems like we see down here in example 2. So let me scroll up a little bit, give myself some more room. And we need to find the value of these variables in the 4 triangles for example 2. And again, we're going to leave our answers in simplified radical form. So to start with, for A, I'm going to write out my 2 formulas. H equals 2 times s and L equals s times the square root of 3. Now I'm going to fill in, in both of these formulas, fill in what my picture gives me. So let's label real quick. There's my hypotenuse. Across from my 30 will be my short leg, and this must be the 60-degree angle up here, so across from that down here, that is my long leg. So my h is A equals 2 times my short leg, which is 4. Now we can see right away that's going to be pretty easy. We'll come back to it in a second. Let's come over here to this other one. Long leg is B, short leg is 4 times the square root of 3. Okay, so this one looks pretty easy. I realize that A is going to be equal to 2 times 4, so that means that A is equal to 8. And B is equal to 4 times the square root of 3, which we're just going to write as 4 square root 3. Okay, so that was pretty simple. We used our 2 formulas, we filled in what the picture gave us for each of the letters in the formulas, and it gave us these 2 answers. Let's look at letter B and see if this one's going to be just as easy. I'm going to start by labeling my side. So across from the 90, there's my hypotenuse. Here's my 60, so across from that is my long leg, and that must be the 30-degree angle up here, so A is going to be my short leg. Now I'm going to write out my formulas. H equals 2 times S, and L equals S times the square root of 3. And I'm going to fill in what the picture gives me. H is 4, equals 2 times S, which I said was A. Okay, that doesn't look like it's going to be too bad. I should be able to solve that. I'll come back to it in a second. L is B, equals short leg, which is A, times the square root of 3. Okay, so I see I have a problem here. I have two unknowns in this formula right here. But thankfully, if I come over to this one, I'm going to know that my A is equal to 4 divided by 2. If I divide by 2 on both sides, it's going to leave my A by itself. 4 divided by 2 is 2. So now I know my value of A. I can put it in right here. B is equal to 2 times the square root of 3, or just 2 square root 3. So I didn't initially have enough information to work out this formula, but once I did this side over here and found that my A value is 2, I could put that in there and I could find my B that way. So here are my two values for example B. Coming down here to example C, it's going to get just a little bit trickier. Let's label the sides first. Of course, this is my hypotenuse because it's across from the right angle. Here's my 30-degree angle, so B is my short leg, and that leaves this angle up here to be my 60-degree angle, which means that A is my long leg. I write out my two formulas. H equals 2 times S, and L equals S times the square root of 3. Again, if you write these out for every problem, eventually you're going to have them memorized without really having to put much effort into it. You're just going to have to write them out. It takes about 5 seconds for each problem. H is 4 times the square root of 3 in my picture, equals 2 times short leg, which is B. So I know that right here I should be able to find B. I'll come back to it in a second. L in my picture is A. S for my short leg is B. So I do have a problem here. I have two unknowns. But if I come back over here, I should be able to find one of those. Now, if 2 times B is going to be 4 root 3, then if I divide both sides by 2, that's going to isolate my B. 4 root 3 divided by 2, I can cancel out the 2 on the bottom and divide the 4 by 2 and turn it into 2 root 3 on top. So 2 square root 3 is my value of B. Now over here, I now can put that 2 square root 3 where my B was, but I don't want to forget about this square root 3 out here. This thing didn't take care of this square root 3. That square root 3 came from my value of B. So now I have A equaling 2 square root 3 times 3. So we're looking at 2 times the square root of 3 times the square root of 3, which is 2 times 3, because we know that these two multiplied together just give us the 3. And so A has a value of 6. So 2 root 3 and 6 are my values for C. Lastly, let's take a look at D. Label our sides. Across from the 90 is A, which is going to be our hypotenuse. Across from my 30 is B. That'll be my short leg. So that means that this is my 60-degree angle and that is my long leg. I write out my formulas. H equals 2 times S, and L equals S times the square root of 3. I fill in the given information that I have for my variables down here. H is an A, equals 2 times S, which is a B. Okay, I have two unknowns there, so I'm going to have to come back to that one. L is my 5, equals S, which is my B, times the square root of 3. Only one unknown here, so I should be able to solve for B. I'll divide both sides by the square root of 3 so that these cancel and I'm left with B by itself. But that means I have 5 over the square root of 3. So I need to take that and rationalize that denominator by multiplying by the square root of 3 over the square root of 3. That's going to be 5 times the square root of 3 over 3 for my value of B. Take that value of B and use it right here in this other formula. A is going to be 2 times 5 square root 3 over 3. So that's a 2 over 1 times a 5 root 3 over 3. It looks ugly, and I know it involves fractions, but we should be able to do this pretty well. We're going to multiply the numerators. 2 times 5 root 3 is 10 root 3. Multiply our denominators. 1 times 3 is just 3. So 10 root 3 over 3, that's our value of A. And that's about as tricky as these 30, 60, 90s are going to get. Might have some pretty ugly answers that we have to do some rationalizing the denominator with and things like that. But again, my biggest piece of advice, start every one of these problems by writing out these two formulas, then fill in what the picture is giving you and solve for what you can solve for. All right, folks, good luck doing the practice problems on these, and we'll see you in the next video.